In this video, we're going to talk about the quadratic formula. And before you start this video, you should know generally what is a quadratic equation, it is x squared, what are the order of operations, what are imaginary numbers if we have the square root of a negative, and how do you simplify square root. So all these things go into using the quadratic formula correctly. All right, so in the grand scheme of mathematics, quadratic equations are very consistent. There's only three numbers we can do. We can just pick any A, B, or C. And we know all their graphs look pretty similar. They're all just these parabolas. Right, so they're pretty consistent. And because of that, there's actually an algorithm, a kind of set equation that gives me the answers to all these quadratic equations. All right, and this is the thing known as the quadratic formula. It's a formula that you just plug the stuff in and it gives you out the answer. So the quadratic formula is going to come up a lot in your math career. You might have already seen it, all right, but this is the formula. And it's just something you have to memorize. All right, there's some videos online of people saying it to the tune of Pop Goes the Weasel, and that seems to help some people memorize it. All right, but once you use it over and over again, you'll just have it memorized. All right, but this is something you definitely want to memorize because it's just something that's so useful. Every time you see a quadratic equation, you can solve it using this formula. All right, so here's a general strategy of using the quadratic formula. The first thing you have to do is you have to get it in this form where 0 is on one side and all the like terms and stuff are combined. It has to look like that before you can do the quadratic formula. All right, but then what you're going to do is plug all those numbers in. So A is going to go in the correct places, B in the correct places, C in the correct places. And notice the A without the X's. So you don't care about the X's once you start using the quadratic formula. They just tell you where A, B, and C are. All right, then you want to fully simplify the square root. All right, making sure if you have a negative in there, you get an I. If you have perfect squares in there, you simplify it. And if it's possible after that, see if you can simplify it a bit further. But really the quadratic formula is all about setting it up and just simplifying correctly. All right, so this one, 3x squared minus 2x equals 3. Can't use the quadratic formula yet. Before I do that, I have to subtract 3 from both sides. But once I have that, I now know my A value, my B value, and my C value. And make sure you include those negatives with B and C. So the quadratic formula says that the answer to this equation is negative B plus or minus square root of B squared minus 4AC all over 2A. All right, so it's just always this formula, just had to have it memorized. But now I'm going to put in negative B, so that's negative 2 is positive 2. All right, so be careful with that very first thing. All right, negative 2 squared minus 4 times 3 times negative 3 all over 2 times 3. All right, so second step after you write the quadratic formula, just plug in the correct values into each part. Now the main thing you want to focus on is that square root. So the square root, negative 2 squared is positive 4. Negative 4 times 3 times negative 3, that's negative 12 times negative is positive 36. And that's all over 6. Combine those, I get 40 over 6. So this is like the first good place to kind of stop and catch your breath, because once you get down to just a single number in the square root, it's already a lot easier to look at and you kind of know where to go from there. So this is kind of stage one. Now from here, we want to look at this square root and see, is it possible to simplify this square root any further? We have two things we could do. If we see a negative in there, we're going to use an I. And if we have any perfect squares, remember the perfect squares are these numbers, we're going to divide or pull those out because they interact nicely with the square root. So in this case, 40 is 4 times 10, and 4 is a perfect square, so it becomes a 2 when it moves outside the square root. Right. And if you got down to here, I'd be perfectly happy. This would give you full credit for using the quadratic formula, but it turns out all three of our terms, all three of these are separate terms. They're all even. They all have a factor of 2, so I can divide everything by 2, and I can write a slightly smaller answer like that. And that very last step isn't completely necessary, but it's a good habit to get in of, can you simplify even further? The reason I don't want to force you to do that is because some people simplify too much. So just getting here, I'd be happy with. But if you recognize all three of your terms are divisible by the same number, do that to get a simpler final answer. All right, here's another example. It's already set up for us because it's equal to 0. So now we know A. What is B? If there's no number in front of X, B is 1. And C is negative 1. All right, so if I was doing this problem, I wouldn't write the square root every single, or the quadratic formula every time because I have it memorized, but putting it on the slide so that you can see it every time and just helps you memorize it more. All right, so negative b is going to be negative positive 1, so negative 1. 1 squared minus 4 times a times c over 2 times c. And the main focus at the start is doing the square root. 4 times 6 is 24, over 12. All right, and again, remember, this is kind of your first stopping point. You can kind of take a breath. You've done the quadratic formula. You've simplified inside that square root. All right, this thing is known as the discriminant. You don't need to know that. All right, but once you simplified that, it looks a lot simpler. And now your next question is, can I simplify the square root further? And you can, because the square root of 25 is just 5. And this is nice because the square root completely goes away, but it actually means we have a little bit more work to do because when the square root completely goes away, I can actually write this. I can actually combine these two things on the top now. So I could do -1 plus 5 is 4. All right, and that simplifies down to 1/3. Or I could do -1 minus 5, that's -6. That simplifies to -1/2. All right, so if the square roots completely go away, you can actually get down to much simpler answers that don't look as complicated as that. All right, so just make sure you recognize you can keep simplifying further if the square root goes away. All right, next problem, we have to do a bit of work at the start. All right, you can move stuff. I like to keep, for no reason specifically, I like to keep the x squared term positive, so I'm going to subtract x and add 3 to both sides because that'll keep that positive thing on the left. And now that I have 0 on one side, I can do the quadratic formula, which again, I'm just going to write because we're still learning it. Negative b is positive 1. Again, it's really focused on that square root first. -1 squared is positive 1. -4 times 5 times 3 is going to be 20 times 3 is 60. And then I can subtract those two numbers. And again, remember, this is your first stopping point once you've gotten down that discriminant, that square root, into a single number. And here there's not much I can do. All I can do is remember that if I have a negative in a square root, I can write that using an I. And now I'd have to ask myself, is 59 divisible by any of the perfect squares? And I'm pretty sure 59 is prime, so I definitely don't think it's divisible by anything, let alone one of the perfect squares. So I'm pretty sure this is our final answer. All right, but if I had gotten down to something like this, I could keep going because 20 is 2 squared of 5. All right, but in this case, 59 was the square root we had, so we just leave it like that. All right, so here's one for you to try on your own. All right, solve this quadratic using the quadratic formula. All right, I'll show you the answer in 3, 2, 1. And if you fully simplify this, you end up getting 3 and -3 halves. So some people might have stopped here, but just remember, when that square root goes away, you can actually do the plus sign. 3 plus 9 is 12, or 3 minus 9 is -6. So once you get rid of that square root, you can actually find a numerical answer that's much simpler. All right, so go ahead and practice using the quadratic formula. All right, if you have the formula memorized, then you just follow the order of operations and simplify using things you already know how to do. All right, if you want to know where the quadratic formula comes from, all right, stay tuned for the next slide, and I'll kind of do a demonstration of where this formula, it seems like it comes out of nowhere, but it's really something you already know how to do, just a little bit more complicated. All right, so go ahead and practice, and if you want to see where the quadratic formula comes from, stay tuned. All right, so here's where we're going to show that where this quadratic formula actually comes from. All right, so ax squared plus bx plus c equals 0. We're going to solve this generic quadratic without knowing what a, b, and c is. So if any a, b, or c comes up, we can do it. All right, we're going to do this the same way that we learned before, by completing the square. So by completing the square, first thing we do is get the c to the other side. And now when we've done completing the square before, we haven't had a number in front of x squared. So what we're going to do to get rid of that a is just divide everything by a. So we're completing the square. The only extra thing that we haven't learned so far about completing the square is having to divide by a. Now what do we do in completing the square? We identified b. It's the number next to the x. So I'm going to use a capital B. Is b over a. We have to divide it by 2. Dividing by 2 is the same thing as multiplying by 1/2. Then we have to square it. If we square that, we get b squared over 4a squared. So that's the thing I need to add to both sides. Again, it's complicated because it's all these variables and it doesn't simplify nicely like numbers do, but it's still the same process. So we add b squared over 4a squared to both sides. All right, and if you remember completing the square, this left-hand side now is going to factor with that. So it's going to be x plus b over 2a all squared equals the right-hand side. All right, on the right-hand side, there's two different fractions, so let's combine them. We have to get a common denominator, so we need to multiply this left-hand fraction by 4a on the top and bottom. That's going to turn into negative 4ac over 4a squared plus b squared over 4a squared. And we combine them. I want to write the positive thing first because it normally looks nicer. The b squared is positive. We subtract 4ac, and that's all over 4a squared. And that thing on the top of that fraction might look similar because it's in the quadratic formula. All right, but the next thing, now that we've created our perfect square, we take the square root of both sides, which gets rid of the square. On the right-hand side, we get a plus or minus. And now square roots we can split up over division. So on the top, I'm just going to have the square root of b squared minus 4ac. On the bottom, I'm going to have the square root of 4a squared. But what's the square root of 4a squared? Well, the square root of 4 is 2. The square root of a squared is a. And now the last thing, to get x all by itself, I have to subtract b over 2a from both sides. And luckily, now x is by itself. On the right-hand side, these already have a common denominator. So I can combine them, and I'm just going to write the negative in front for some reason. Put the negative b in the front. I'm going to combine that with the plus or minus the square root of b squared minus 4ac. Divide that by the common denominator, 2a. You notice this is exactly the quadratic formula. So we just proved where the quadratic formula comes from. All you do is complete the square with its generic quadratic. All right, and it looks really complicated. There's a lot of letters all over this page, but it's all steps you've done before with numbers. Moving this over, dividing this by 2 and squaring it, adding it to both sides, combining fractions, taking square roots. We've all done this before. All right, it's just the fact that now you're doing it with letters instead of numbers. All right, but this is just showing where the quadratic formula comes from, so you don't think I just made it up or some magic happened that made the quadratic formula. It's all stuff you've done before, but you just do it with letters instead of numbers.